not ice cream.
Right.
It's snow though.
On your homework, I'm pretty sure at least 2 of the 3 problems I gave you yesterday are worded just like this. And again, Kimberly.
Let's be mean.
I don't hear Caitlin, I hear you.
She whispers mean things.
She does every day.
I think the book words these questions weird, but I want you to be able to do your homework, so I'm wording it the same way that the questions on the homework are worded. But on the test, I'm not going to word it so weird. Like, I'm going to say, find the linearization. Use that to approximate, kind of like we did the first one. But if you did the homework last night, those 3 questions, you saw that it was worded like this, and you might have been like, what does this mean? A of point plus 0.1. But 2 things we're doing here. We're going to find the linearization, which remember is just a tangent line, at the point that they give us. And in this case, they're giving us the point of 0. They say a equals 0, and I kind of am sad Sean's not here to argue with me about a and x, because you really could say x equals 0, right? But that's just the point that we're talking about. And then the second part is they want you to see how accurate the linearization is. And so that's the part where they say, estimate, show how close is the linearization when you add 0.1 to the actual value of the function. But step 1 is you have to write that tangent line. And remember, you can use the formula that they gave you, which I always remember when I teach it, but then like 2 months down the line, I forget it. And so that's why I say just write the tangent line and solve for y. So what do we need to write a tangent line? A point and a slope. Do we have a point? Good part of a point, right? So if we know if 0 is the x-coordinate, how do we find the y-coordinate? We plug it in, so I can say f of 0 equals ln of 0 plus 1, which is ln of 1. What is ln of 1 without a calculator? 0. Right? What did you say?
I know it.
We also need a slope, and how do we find slope in calculus? Derivative. So I'm going to find the derivative, and then I'm going to plug my point in. Oh, we haven't had derivatives of ln in a while. How do we find the derivative of ln? Yeah, remember the derivative of ln of u is u prime over u. Can you believe our finals next week?
And there's going to be like limits on there.
I know.
Really? That's just what I keep
Yes.
thinking about.
No.
Just put it on the final. That's a good idea.
I told my husband last night when people were calling to our delays for other schools, I said, if we have a 2-hour delay, I'm quitting teaching. And he just kind of rolled his eyes. Like, well, no, I don't mean like I'm quitting my job. I just mean I'm done. Like, I'm done trying to cram test it, and I'm just going to be like, whatever. We're starting reviewing. I'm over this 2-hour delay business. Like, I can't handle any more delays.
Just add this on to the final and just forget another test.
And then we can just
No, we need the test to help.
Yes, we need a test to help you.
Sorry, guys.
That's the thing. Like, some people are okay with their grade right now, but some people want another test because, you know, they have the chance of raising your grade. But then there's a chance that you can lower your grade too. And so it's just, the plan is, unless we have more weather delays, we're having a test. Because we'll be okay.
Wait, so what do you have to wait?
I'm done. I'm quitting. I'm telling you. We have one more delay.
Whatever, you say that now. You would make us take it.
Because right now, look where we are. Look on the board. Like, we have 4-6 tomorrow and Thursday, reviewing on Friday. Right now, our test is Monday. Your final is Thursday. We have any more delays, like, we're done for. We're going to be taking the chapter test on the final day. So,
Let's just make that our final.
you can't. Mr. Puckett says we have to have a cumulative final.
But you can put a limit on it.
One limit?
One limit.
Wait, what if we just miss like a day of finals?
We'll cram it all in.
All the freshmen were asking.
Remember that, I don't know. I've been here a while now, so I get
we
the
have
years.
to take them in January.
Well, if we missed all those days, we'd push them back. But if we just had a 2-hour delay, or we missed one day, we would just cram in multiple finals on the same day, and they would shorten them, which means we'd have to shorten our finals. And so, like in pre-cal, I have a 50-question final because I planned for it to take most of the 80 minutes. But let's say we had a 2-hour delay, and they shortened that to a normal class period, I'd have to shorten my final. And
Let's just do that anyways.
Can we miss like Wednesday or something?
oh my gosh, let's do this and just be done and be ready for a test. All right, I saw the weather today, and I don't think we're gonna miss any more days unless something crazy happens.
Ms. Hodge said that this is going to be a very unpredictable winter. So you never know when something's going to happen.
Miss Hodge hopes for a snow day every day. So,
She does her job.
like in the long scheme of things, she stresses about snow days, but like every day she just gets so happy. It's a snow day! Like she just is that kid at heart. Like I don't know. And whereas me, I'm like I can't do my testing now. We have a snow day. What is u in this problem?
X plus one.
U is x plus 1, so u prime is just 1. So the derivative is just u prime over u. That's not so bad, right? So when you plug 0 in there, what's your slope? It's just 1 over 1, or 1. Again, is it required that you have to do it this way? No, you can use that L of x formula. But this is what we're going to be doing all year. We've been doing it all year. We're going to continue to write tangent lines. I can guarantee on your AP test there will be a free response question that one part says write the tangent line. And so I feel like this prepares you instead of making you memorize this extra formula. But then you just have to write it and solve for y. And then we just replace it with that L of x, since that's what they call it, the linearization. So point slope form, y minus y equals my slope times x minus x. Why did I put 1 in there? 0, right? My point's 0, 0. My slope is 1. So is that just the line y equals x? I'm okay if you leave it as y, but they like to call it L of x for the linearization. So again, if you want to kind of match the way the book's doing it, then we could change that y to L of x. But if you just wrote y equals x, I would count that right. Like y is the same as L of x. Well, on the AP test, if they're asking you about linearization, they're going to ask you like what the value is, so it's going to be a number answer more than L of x. But yes, they would count that as well. So this is write the linearization, and sometimes like on the test, this test, I'll give you a question that just says find the linearization. Like that's it. That's the tangent line that goes through that point that we can use to approximate. So then the extra part of this is they just want you to see how accurate this is, how you can use this to estimate values. And we talked about yesterday, back in the day when people didn't have calculators so readily available, like in Isaac Newton's time, no one had a calculator. This was useful to estimate values like this. So when it says do L of A plus 0.1, the reason they write the directions like that is because A is different in every problem. In this problem, our A was 0. So we just want to estimate 0 plus 0.1, or that would just be 0.1. Follow me on that? If A was 7, we would do 7 plus 0.1. If A was 2, we'd do 2 plus 0.1. And I'm just going to plug that into my linearization. And since it's just x, do you agree I just get 0.1 back out of that? And they want you to compare that to the value of the function, because the idea is these linearizations give us a pretty close estimation. So now we want to do the same thing, but plug that into the actual function. So now you're going to plug in f of 0 plus 0.1. And this is where, what would that be? 0.1 plus 1 would be 1.1. We have to get our calculators and type that in. Unless you want to get out the old slide rule.
I don't even know that. I've never even heard of it.
There used to be a giant one in the store clerk closet, but I feel like I got rid of it. Because when I used to see,
I think we used that, but it's not like a giant ruler except it's 3/4.
yeah, it's like a big,
Like we have
yeah,
one
and they
side
used to
here
have a big classroom one here when I first started teaching here. It's like this big, with the normal one's like the size of a ruler, maybe smaller. But there used to be the one that they used to teach people with, and I would always get it out to show people. And it was like this big.
Is there LNs on it?
No, it just has a bunch of decimals, and I don't know. In my history of math class, I learned how to use one because you don't use them anymore. I had to. I'm a math major,
That's good.
I took a history of math class, and everyone had to do a project of one part of math of history and present a less number. So someone did the history of pi, and someone did the history of e.
Did you do the slide?
I did a very boring thing. I did this Chinese mathematics 9-chapter book that all the books in China were burned at one point because the emperor of China, does that sound right? I don't know. A very, very long time ago, decided that all books were bad, so they burned in it, and it was saved, and then I did another lesson over it. Not that cool. But one person did the history of abacus. You know what abacus is?
Yeah, we have one.
That you like count with, like has like beads on it, and you can count.
That doesn't actually have numbers. It's like a.
Right. Doesn't have
Yeah.
numbers.
What do you use?
Basically counting on your fingers.
It's counting. But primitive, like it was useful long time ago. And our homework, like we had to present a lesson, and then you had to give homework for the lesson, and the person that did that lesson made us make an abacus out of something. Like make your own abacus. That was our homework. And I was so mad because I was a college student, and I was like, I'm not going to the store and buying stuff to make this. So I made out of my outer border was fettuccine noodles. And then the inner border was spaghetti noodles, and I just put Cheerios on there. It was very, very fragile.
Yeah.
I think I glued them together. I don't know. I don't
And
remember
you
at this
carried
point.
it to class.
And then I carried it very, very fragile. Don't touch me, my
I would be mad
abacus.
if they would have made me do that.
I was kind of
This
mad.
is probably your
bad.
bad. You're making me do this.
And then someone's dad helped them, and they made this big giant one out of wood, and I was like, whatever. Way to have a great parent in your life.
Freshman year.
No, it was my junior year.
Someone had their dad.
It was awesome abacus. I mean, it was really cool. Because they're like, I'm going to save this when I'm a teacher. And I'm like, yeah, mine's going in the trash.
You don't still have your spaghetti noodles.
I don't have my spaghetti noodle. But I remember how mad I was gluing it together that weekend. I was like, who gives us assignments?
Mine is so bad. I have this stuff. I have a note contest. I don't know what.
If you do ln of 1.1, you get 0.953. Is that pretty close to the estimation that we got? 0.1?
No, it was 0.0.
0.096. Got a little issue there. 0.09, if you rounded, would round up to 0.1. And so think about if you didn't have a calculator or even a slide rule and you couldn't do 1.1, right? This would be really useful because you could get a really accurate answer when you didn't have a calculator. All right? Again, we have calculators now, so it's not really that cool, but I think it's kind of cool. I think they just compare them. They just say 0.1 approximately equals 0.0953.
Kimberly and I just said very accurate.
How accurate is?
Accurate,
That's
but
funny.
it's not accurate.
They just want you to compare the two. I guess they shouldn't say how accurate is it. They just want you to see the two numbers. If you would have got that they weren't accurate, like I forgot my zero there, if you would have got 0.1 and 0.9, then you've done something wrong because it should always be very accurate if you did your tangent line right.
We're never going to say not accurate.
Right, you're never going to say not
That
accurate.
really is a bad answer.
So if you get that they aren't very accurate, then something's wrong. Like either you wrote your tangent line wrong or you plugged something in wrong because it should always be very accurate. It's only very accurate if you're really close to that point. So notice the reason that they have you just add 0.1 is because if you get really far away from that point on the tangent line, it's not going to be as accurate anymore. But just right around it is pretty accurate. And if you think about that really quickly here, if we think about what we talked about yesterday, like here's my curve, here's my line. That's A. If I get really close to A on either side, I'm almost on that curve still. But if you like add 7 and you get way out here, that's not going to be very accurate to the actual curve. So that's why they always ask you just to go like 0.1 away, because that's the only time it's accurate. Okay. So that's the use of tangent lines. How about that? The other part that we didn't get to yesterday is differentials, and they're actually, compared to some of the stuff we've been doing, not so bad. It's just kind of understanding what it's doing. It's just another way to look at derivatives. So it says let y equals f of x be a differentiable function. And instead of thinking about dy dx as one thing, right? You guys always like to write y prime, and you get mad every time I write dy dx, or especially if I change it to another letter. But when we're talking about differential functions, it's really important to think about this dy dx. And think about that this is a division bar, right? Like we normally think about it as just a symbol, but this is dy divided by dx. And do you agree that that's the same as saying f prime of x? The differential is when you solve for dy. So if I wanted to get dy by itself, what could I do to this problem to get dy by itself? Multiply dx over, and do you agree that you now have equals f prime of x times dx. That is a differential equation. When you separate them, when you solve for dy, and the big thing I want you to practice doing is just being able to find the derivative and multiply by dx. What's the use of this? Dx can be thought of as a little change in x, or like an error, like you can compute how much error something has using differential equations. We're not going to do a whole lot of that. But, oh, there you go. Differential of y can be used as an approximation of the change in y. And then in your book they go into computing error. But you're going to see, I kind of gave you a lot of homework, and you're going to be kind of like, why did she give me so many problems? So you're going to see that these are pretty easy.
We still have the
Maybe.
work and the worksheet.
Kind of fun to do.
We don't have to work. She was just gonna say we have to write in the shift.
So here we go. What are you reading right now, English?
Oh, you could pick
Oh, you can pick. Write a paper.
1984. The paper is something different. But 1984 is the first book I wrote.
1984 is tough to read. Like, I don't know, the copy of my book that I had in 1984 had like no margins, and I felt like it took me an hour to read through one page because it was just so much ink on one paper. It takes a while to get into 1984, but it's kind of a crazy book.
It reminds me of North Korea.
It is, like, it's kind of, it reminds me of the movie The Matrix.
I'm not saying that, but
Oh
I
my
just
gosh.
think of North Korea all the time.
It reminds me of now.
Hey, did you give me
Yeah, he was really happy.
I'm pretty sure someone said that they're watching it in class.
Yeah.
Is he just not
So
gonna
you're in Dallas.
He's
Yeah,
not.
we're watching that. on Friday.
So here's the big thing. When you see find the differential, you have to know that means solve for dy. If you want to write it as dy dx and then solve for dy every time you can, or just know that if it says find the differential, you're just going to do dy equals the derivative times dx. And notice they give you a function, they give you an x value, and they give you a value for dx. So dx is not just a symbol to mean the change in x anymore. Like, they're telling you the change in x is 0.01. And so you actually can get a numerical answer if they give you this. Can you take the derivative of this? That's not so bad, right? This is just power rule here. So the derivative would be 5x to the 4th plus 37 times dx. If they didn't give you this part, which we're going to do in a minute, guess what? That's your answer. That's all you got to do. It's like chapter 2 stuff, right? Chapter 3 stuff. Let's just plug it in. But now we're just plugging in. Plug in 1 for x, plug in 0.1 for dx, and give me a numerical answer for what dy equals. What's 1 to the 4th power? 1, right? Just so I can make sure we're
Makes me
clear
feel
on that
like
one.
I'm wrong in thinking that I'm right.
So what is that? 42 times 0.01? Or is that just 0.42? Again, we're not going to get into too much of the computing error on this because it's just not something that's stressed on the AP exam. And if you take differential equations, like if you're going to be an engineer, you're going to take differential equations and you're going to go into this way more than we are. So you at least have some idea about it. But it's a nice little review of derivatives because we haven't done that in a while. So try this one. Trig is important. So you try this one. Oh, and then sine is 3x, right? So I think that's a chain rule derivative. Not just cosine 3x. Times the derivative is, right?
Memories.
Having a final soon,
Yeah.
It's kind of scary to me.
I honestly, I did not. You don't even have to take it, Miss Dixon. Your grade is not counting on this time. Imagine how we feel.
But I have to get you ready
Charlie was very upset.
Ron called me the devil.
And then she said, you can't talk for 5 minutes. We told her that
Sometimes
we were
you-
gonna fail the AP exam on purpose, so that she looked bad.
No, Claire said that. That's terrible.
She was being extra.
If this Crone was or Kimberly was? Well, both of them.
Everybody was.
She gave us a pop quiz. You're not allowed to do that, Kimberly.
No. And then
It
she
seems
was
like
like,
you
well,
just
what do you guys want to do at the end of class? And Claire's like, we're not doing anything. She has no control. And the class is so small, I don't know what's like. It's Sean in there.
Is there gonna be other people in there besides Sean?
Sean, Tyler, Neil, and Katie. So I don't know if
Mallory
Tyler's-
might be coming.
I'm gonna drop
Mallory
out
be
of that
doing
class.
this?
I'm dropping out of that class. Remember that anytime you have a trig function of something other than x, that's a compound function, and so you have to remember to multiply by the derivative of the inside. And on your final, there's going to be a whole lot of derivatives, and it's multiple choice, which that's not so bad, right? But if you forget to multiply by the inside, I guarantee that's going to be one of the choices, because they know that's going to be the mistake that you make. The derivative of sine is cosine, but then you have to go back and take the derivative of the inside, which would be 3, so 3 cosine of 3x dx. And then we're just going to plug our stuff in. 3 pi times negative 0.02. What is the cosine of 3 pi? 2 pi, 3 pi would be over there. And cosine is x or y? X, so over here, it's negative 1, 0. So that's just 3 times negative 1 times negative 0.02. So 3 times 2 is just 6, but it's 0.06. And the negatives make a positive. Yes? That's not bad, right? I was really hoping I could cram this in yesterday, because it really isn't a bad word. I know. And the last one is the best, because they don't actually even give you any values. If it just says find the differential, and again, I think one of the hardest things about calculus and about calculus tests and AP tests is understanding what it's asking you to do. When it says find the differential, that means find dy. And this just means the differential of this, so you just have to do dy equals f prime of x times dx. And you leave your answer like that. D just means derivative, like it's just another way of saying find the derivative. Like earlier when I wrote the rule for ln, if I said find the derivative of ln of x, like that's what that means. It just means take the derivative. So I'm going to give you a minute and see 1 minus x squared to the 1/2, right? Chain rule, see if you can take the derivative of that before I do it for you. Don't forget to multiply by the derivative. Alright, we bring out the 1/2, subtract 1 from the exponent, but don't forget to multiply by the derivative of the inside, which would be negative 2x. And then we have to put dx there, and probably just like on the last test we had the antiderivative, and some people forgot their plus c. On this test, what you forget is the dx. You have to just remember that it's in the dx up in. And then we should simplify this a little bit. I'm okay if you leave a negative exponent, but I'm okay if you get rid of the negative exponent also. But I really think that you should, cross those 2's out at least. Clean it up a little bit. Since I did that, I'm just going to go ahead and say that on the top I have negative x, and I'm going to go ahead and move that down to the bottom. But if you didn't, if you left that as the negative 1/2 power, that's okay as well. Yeah. You mean like with the dx up here? Like multiplying by dx out here is the same as putting dx up there. So it's just whatever you like. That's what's awesome about math. So you need to finish this homework. If you didn't do 1, 3, and 5 yesterday, then you have 3 more added on today. But 19 through 25 all and 28 through 30 all, I'm pretty sure those are all differentials, which are not very bad to do. I also have a worksheet over this optimization because I feel like if you weren't so close to time, I would give you that anyway. There are 4 questions on the front over optimization, over 4-4. That you're required to do. The backside is differential, which is what you're doing. So you don't have to do the backside. If you want to do the backside, maybe I'll give you a couple points extra credit. If you do it right, I'll let you.
If only if we do it right, they're not.
Only if you do it right.
One point for each one. Right?
Yeah, I need that A plus.
What's optimization?
That's the next one in, like maximizing your mind. That's stuff that we really need extra practice on. And I feel like we have examples of most of these. Number 3 is from a piece of cardboard, the corners are cut off, like that question that we did in class. You're going to see a question like that on your test. So good practice. So 1 through 4 required, so that's added onto this. Backside not required, but it's not that bad either. I'll give you a couple points extra credit if you do it. I'm not committing to 1 point per problem, but I'm committing to half a point per problem, which would be
That's
2.
That's 2.5 points we didn't have before.
Today is pride time.